Welcome to the 9th mini lecture in 7505 NSC Project Management. The previous lecture we looked at the basic concepts of project scheduling and also how to develop networks, and we got to the stage towards the end where we could be given a table giving activities, their description, the times and also the predecessors, and we could construct that network and work out early start, early finish and so on. In this lecture we're going to extend that concept further, and we're going to go into what we call project lagging, crashing projects. Now, crashing projects is a little bit different from what you think. Crashing projects is simply trying to speed up the project if it's gone over schedule, trying to get it back onto schedule, and the different network types. So what we're going to be doing in this is first of all describing the use and advantages of Gantt charts. These are charts that are part of the different software tools such as Microsoft Project, Open Plan Professional. We're going to be describing lags and their application in precedent late and that relationships, and seeing as to this is another little tool that project managers can use to actually get finer definition in their schedule. We're going to be identifying the method of accelerating or crashing projects, including their strengths and weaknesses. And this is particularly important because it is not always bad that a project finishes late. That is, it may cost more to finish it on time in terms of paying overtime than paying the penalties of finishing late if there are penalties. We're going to explain how trade-offs are used in deciding whether to accelerate projects, and then we're going to extend further in talking about how activity on arrow networks are used as well as the activity on node that we've been discussing up until now, including their advantages and disadvantages. Gantt charts themselves are part of any project management tool, and the important thing about Gantt charts is that they give us a time-phase network. They can be used as a tracking tool. So here we have a Gantt chart where we have the activity identifiers, A up to H. We've got the different names for those identifiers. We've got the durations put in there. And then the Gantt chart is the calendar section, which explains in terms of a 7-day week as to where each activity fits. And because we've already put in the predecessors that are not shown in this chart, we can see where we've got parallel activities and where we have serial activities. And so straight away we've got an immediate visual idea, first of all, as to what the network looks like. We can see immediately when it starts, and we can see immediately when it finishes, and we can see for each activity as to its start and finish dates and which ones are done concurrently and which ones are done in serial. So a Gantt chart is a wonderful representation. So it's easy to read and understand. It shows the schedule coupled to the schedule baseline. It allows for updating and control. That is, once we, for example, if activity B goes from 5 days to 6 days, we simply amend that and immediately the Gantt chart is adjusted. We can identify resource needs on it, and we'll see this soon, and they're very easy to create using the types of tools that are available. Here we see a Gantt chart, and this is being used to show what the critical path is, and here we can see the critical path in the red. So straight away we know on this critical path that if we increase the length of any of those activities, the project will finish at a later date. And we can simply prove this if we have the working tool by increasing the time and immediately seeing how the project goes out. Whereas on the non-critical tasks, we can see that increasing them up to a certain amount doesn't do anything at all. So again, it's showing us just how powerful this particular tool is. Here we can see again Microsoft Project, and this one not only shows us the task, but it shows the work breakdown structure, where the tool allows the structure to be folded up to show the level 2 activities, and it also shows the level 3 activities all clearly defined. It shows the duration, it shows the start date and finish date for each, and this one has the predecessors put in there to help create the actual network diagram itself. So Gantt charts and Microsoft Project or other software tools basically help speed up the process. They give us greater ease, but they still demand that you know how to create the work breakdown structure, that you be able to do the estimation, and particularly you identify the predecessors. We come to the concept of lags and precedence relationships, and a lag is simply a logical relationship between the start and finish of activity and the start and finish of the next activity. And this is something that's sometimes used in networks to give you a little bit more flexibility. And for example, it could be that when you do a particular task, you might not be able to get that materials delivered on time. And so what we find is that we can actually build this into the network itself. So it gives us this flexibility to work with the network. And what we find there are different precedence relationships. We have the finish to start, the start to finish, the finish to finish, and the start to finish. The one thing we'll learn is the finish to start is a natural relationship, but the others can be used, although we find that there are certain ones, such as the start to finish, is rarely used. But we'll give examples. And just as an example here, for example, if we look at the finish to start, a simple example is washing a car. For example, when you wash a car, you dry it, and then only after you dry it, do you wax the car to polish it. And here we can see the Gantt chart shows them as 3 serial activities. And the one thing we realise is that we have to wash the car first, and we can't dry the car until we finish washing it. If we start drying while the washing is only half done, we'll find that we could get splashing in areas where we've already dried, and that causes problems. It's the same as a waxing. We can't do waxing when part of the car is wet, but also we can't also do waxing before the car's washed. So again, we can see that the finish to start relationship here is readily apparent. And we'll use other examples to show as to what those different relationships are. Crashing or accelerating a project is a process of basically speeding the project up so we either can finish early, or if the project is already over time, we can bring it back to its original schedule. What conditions justify it? Well, first of all, the initial schedule may have been too optimistic. We just underestimated the time for different activities. Or market needs have changed and the project is required by the customer earlier than he originally said or she has said. Could be the project has slipped considerably behind schedule, or the contractual situation provides even more incentive to avoid scheduled slippage. That is, for example, if we're doing maintenance of a Boeing 747, if it's a day late, that's a day that the customer can't be flying the aircraft with 400 seats filled, and so that's a fair amount of revenue lost. So straight away the customer puts in penalties. And of course the options. We can increase the productivity of current resources, that is, we can get rid of it could be a particular tool that makes pieces for the project. We can get a tool that cuts the pieces with computer, and it can cut them at a much faster rate. We can change the work methods by changing technology or the types of resources. We can compromise and say, well, you know, we basically wanted to have a particular finish. We'll take a much cheaper finish. We can fast track the project, and the obvious one after studying critical paths, we can shorten the longest of the critical activities. Or we can partially overlap activities such as programming and debugging, and this is where we can use the actual laddering that we discussed earlier. And we can employ start-to-start lags, such as if it was building a house, we could actually start clearing the site before the council has approved the application, knowing full well that the council, in all cases before, has given approval. So there are different things. And of course, using overtime or adding resources to the project team. Here is a diagram which shows the time cost trade-offs for crashing activities. And the one thing that we realise when we study this diagram in detail in the lecture is that what we have to do is to be able to actually sit down and saying, okay, if we actually want to reduce the time, we're going to have to pay an extra cost. whereabouts does it become unviable to continue cutting back the time at the extra cost? And so this is something that we do in different examples that we'll study during the course. Here is one where it's an example we work through during the actual course itself, and this shows the project durations, the direct costs that we studied in an earlier lecture on cost estimation, the liquidated damages penalty, and also the overhead costs. And we find out that if we want to actually reduce the actual times, we find that, of course, the liquidated damages might go down, but in fact the direct costs and the overhead costs go up. And so what we can find out is what is the optimal time that we want to reduce the project to. And we'll learn to study exactly what this graph is telling us. So we now move on to activity on arrow networks. What do we actually study these? Well, whilst activity on arrow aren't used in the aviation industry, they're widely used in the construction industry. So we need to be aware that it is a technique that's used. The activities, as we said in a previous mini lecture, are shown by arrows, and the event nodes are easy to flag, and of course the forward and backward pass is similar to the activity on node. So there are a lot of similarities, but we'll see that the difference between activity on arrow and activity on node is that it is very hard to depict certain parts of the network. So we have to use this concept of dummy activities. And so we'll see as the way the dummy activities are used. So at the top of this diagram, we see the activity on node network shown. At the bottom, we see the activity on arrow shown. And we see that once we get into parallel activities with bursts and merges, we get into difficulties trying to do the same things. So the dotted line represents the dummy activities, and we'll be showing as to how these are used as part of the actual alternate ways of depicting a network. So in summary, we've spoken about Gantt charts and how we can use them, and just how much easier they make reading a network for us, as well as constructing and adjusting the network. We've described lags, the 4 different types, and their application precedence relationships, and we've learned that one of them is used far more than the others. We've identified the methods of accelerating or crashing projects, and we've looked at their strengths and weaknesses, and we've found that in doing the cost trade-off, we actually find out where, as we try to reduce the time for a project, the cost goes up, but the penalties go down. But at a certain point, we say it's not worth trying to reduce the time any longer. And we've looked at the difference between activity on arrow networks versus activity on node, and we've seen exactly where these are used in the future. This will give us a good understanding as to how networks are done, so that when you use a software tool in the future, it doesn't matter what brand it is, they all use the same principles. And so you'll understand the principles behind the tool, which makes it a lot easier to be able to use it and to be able to manipulate it, to be able to schedule your projects far more effectively and efficiently. Thank you.